Hello class, this is Mr. Hart, and in this podcast we want to continue our discussion of geometry, and we've been talking a lot about areas and finding areas in the coordinate plane, and now we want to move on to volumes of three-dimensional figures, and specifically we want to look at prisms and cylinders. Okay, so let's remind ourselves what a prism and a cylinder are. So a prism or a cylinder is basically when you take a regular shape from the coordinate plane, like a square or a rectangle or a circle, and you extend it out of the coordinate plane, and you just kind of extend it straight up. That's when you get a prism or a cylinder. So for squares, rectangles, triangles, pentagons, whatever it is, okay, that's a prism, like in these two cases. But if you have a circle, we give it a special name, and that is a cylinder. Okay, and so prisms and cylinders we can kind of treat the same, because you're just taking a basic shape and then you're extending it out of the coordinate plane, okay, making it three-dimensional by extending it up, okay? And so when we're describing these shapes or these volumes, the easiest way to do it is just look at the area of that base shape that we know, like a hexagon or a square, and then describe the height of the prism or the cylinder, okay? And so if we're trying to find the volume of this prism, okay, or a cylinder, it's just the area of the base equals, the volume equals the area of the base times the height of the solid. Okay, so I'm trying to find the volume of this prism, whatever it is, and I just take the area of this base that we know from the coordinate plane, okay, and then times it by the height of the prism. Okay, and this works out really nice because it's the exact same thing for cylinders. Still the area of the base times the height of the solid, so you just find the area of the circle using pi r squared, and then times it by the height of that solid. Okay, and so you can kind of imagine where this equation comes from. If you have that shape and then you just slowly build it up to the height of the solid, okay, you're kind of, filling that volume in with, whatever it is. You can think of it in terms of water, for example. You're filling it up with water up to that height, okay? And so that volume is going to depend on how wide you had the area to start with, and then how high you are extending that up, okay? And so it's hopefully a pretty simple equation to kind of understand where it comes from. Just for any prism or cylinder, though, just area of the base times the height of that solid. Okay, so let's try an example problem. So let's say we're trying to find the volume of this prism right here. Okay, so what we're going to do is we're just going to find that the volume is equal to the area of the base times the height of the solid. Okay, and so let's find the area of the base first. Okay, now in this case, the area of the base is this rectangle along the bottom. Okay, let me mark this so you can see it. So this kind of rectangle shape right here along the bottom of the prism. Okay, and so the area of a rectangle from our last lesson we know is just the base times the height, right? Not the height of the solid, but just the height of that rectangle. So in that case, that is 4 for the base or 5 for the base, either way, times 5, which is going to give us 20. Okay, so now we just have to times that by the height of the solid. So the volume is the area of the base, which is 20, times the height of the solid. So 20 times the height of the solid in this case is 10, and so that's going to give us a volume of 200. Okay, and so now we look at units. In this case, we do have centimeters listed, so we want to make sure our units are listed in centimeters as well. And because volumes are cubic, this should be a cubic centimeter. Okay, it's in 3 dimensions. It should be cubic. Okay, so there you go. The volume of this prism is 200 cubic centimeters. Okay, let's go ahead and try another problem. Just make sure we got this down. Okay, so let's say we're trying to find the volume of this cylinder. Okay, well, again, the volume is just going to be the area of the base times the height of the solid. And in this case, the area of the base is a circle. So we need to find the area of that circle along the bottom of the cylinder. Okay, well, in this case, it's giving us this fact that 8 kilometers is the radius of the circle. Okay, and for a circle, we know that the area is just pi r squared. So we do pi times the radius squared, which in this case is 8. So that's going to give us 8 squared, or 64 pi. Okay? I'm going to leave it like that for just a second, but if we now find the volume, it's just the area of the base times the height of the solid. In this case, the height is 10, so we do 64 pi times 10, which gives us 640 pi. Okay? Now, just like in the previous unit, how we had an exact and an approximate answer, we could leave it like this, and that would be an exact answer, or we could put that in our calculator and get an approximation. Okay, so we do 640 times pi, and that will give us, if we put that in our calculator, 2010, or actually 2011 units, about. Okay, not exactly, but about 2011. So there we go. This would be our exact answer right here, and this would be our approximate answer, you could say, is 2011. Now, last thing is check on units. In this case, it's kilometers, so our units better be cubic kilometers. Okay? Cubic kilometers. And there we go. So that's the volume of that cylinder. Okay? So pretty simple to do. We just have to find what area we're trying to find on the bottom, times it by the height of the solid, and that gives us our volume. Okay? So there we go. That's our homework for today. We're just going to be finding volumes of different prisms and cylinders. Okay? Hopefully that all makes sense. Let me know if you have any questions, and thank you for watching.